So, hello there. I'm Lemtopia. Today I'm going to make a better C tutorial. So, let's start. So, first off, you need to install GCC. So, if you're on Debian or Debian based distros, you just sudo apt install GCC. I already have GCC. You can tell if you have GCC if you have this message here. So, let's clear and I'll I'll cd to my programming folder and make a directory called C tutorial. So first off, we need to actually make a file. So you need to make a text file. Let's call it, I'll use Vim because I am used to using Vim. I'll call it main.c because that's a good name. So now we need to actually include some things. So in C, we have a compilation process. Let's actually do this. We have a compilation process, which basically you have the input file. Then it goes, okay. It goes to the preprocessor, which does things, which executes lines starting like basically saying executes lines starting with a hashtag or pound sign. Just that. And I'll just copy these three lines. And then it actually goes to the compiler, which actually compiles stuff. So if you have a line of code and that you need to execute, the compiler compiles it, and then you go to the linker and the assembler, actually go here, which actually makes executable. So that's the compilation process. Oh, of course, we actually need to say that we have an out file. So this is the process, and now we can actually start coding. So first off, we need to tell the preprocessor to include a file. So if we want to write to the console, which we want, we need actually to tell the preprocessor to get the IO module, let's call it that, and just copy it to our project. So we use, remember the pound sign, and we use the word include. This is a valid syntax, and let's open these signs here, and between them we write stdio.h. So this basically tells the preprocessor to pick all of the stuff in the stdio.h and copy into the new output file. And now we need to actually do something with it. So if we try to compile with just gcc main.c, we don't have a reference to main because we didn't actually include made a program. So to doing it, we need to just do this boilerplate, which is int main, open and close parentheses, open and close curly braces. So we actually have a main, and when we try to execute it, it doesn't do nothing because we didn't tell it to do anything. But it is a valid program. So let's try to do something. Let's try to print a string. So if you don't know what is a string, it's just a text. So let's call the stdio function called printf. I'll explain more about functions in another episode, but we open close uh, parentheses and finalize with a semicolon. And inside the parentheses, we need to open quotes and close double quotes. This is really important. Make sure these are double quotes. And we write anything. Let's try to write hello world. So if we try to exit, make, compile, we have hello world. So we have a program, a valid program now. Let's just clear it, and let's see. But it is ugly. So let's try to make a new line. Just add these two characters, the slash backslash n, which will actually make a new line. So in C we actually have escape character sequences, which the new line character is it's a strange letter. So we can't actually type it. We cannot. So we need to use that secret code combination to actually display a new line. So if we cc main.c, a.out, have hello world. And now my exercise for you is maybe try to print 2 lines. So actually, I'll give you a hint. So let's try to make roses are red. So I have a tip for you, which is what happens if you call printf 2 times or 3 or 1,000 times. So okay, let's actually try to do it. Violets are blue. Let's gcc main.c, a.out. Oh, there are 2 lines now. But let's try to remove the backslash n from the first one. Oh my god, it is together. So just by experimenting, by leaving characters and putting characters, we actually can learn some interesting stuff. So remember about the double quotes. Let's try actually putting the code in single quotes. It's actually gcc, and oh my god, there's errors. So we have actually warnings, but let's try to execute. We have a segmentation fault, and congratulations, you made your first seg fault, which is not a good thing, but is one thing that you will always make. Why did I talk like this? Okay, so we cannot use single quotes. So let's stick to double quotes, and let's try to understand better this int main. So int is a data type. Oh, by the way, I should probably say this. So, but you can write comments which will not be executed and not read by the compiler or anything. They are just things to make your life easier. So you can just do this. I actually like the old style, which is / and an asterisk, and to close it you asterisk and /. So this will not be executed. So if to prove it, let's try to gcc, and it doesn't execute. So we can actually try to say a little bit about our data types. We have some data types in C, which is int. And in C, data types are basically sizes of information. So int takes it actually doesn't have a standard. So let's actually change it. Let's include a standard thing. So std int.h. This will make the things a little bit more standard, but you cannot use other types than main. At least you shouldn't. But you have the uint8t, which is 8 bits. Have the 16t, uint16-bit t, which is 16, and so on. The u is actually referring to the sign, so it's unsigned, which means you can only have positive numbers. And you can actually prove it. How can I type unsigned? Can actually prove it by trying to make I'll try to rush a little bit in this. But you intate ta equals -10. So if you actually print the -10, I'll explain what am I doing later. But when you gcc it out, you have a totally different number because the uint is unsigned. So actually you can't do anything that has negative numbers. So int main is a function. Main is the function name, and this needs to be main in that case because it's the main function that every program needs to have. If not, then we will get the undefined reference to main. So we have an int main, and when we have an int function, it should return something. Now, this step in that particular case isn't required, but I like to return number, which if our program succeeded, it should be 0. So return exits the function and gives back the computer a certain value. So if we gcc main.c, shouldn't change. We remove the violet, the rows are red. But okay, we have the simple things. Now let's try to talk about variables. So we need to make a variable. What is a variable? Variables are spaces in memory. So what is memory? Memory is a limited space, limited array of bytes. So we have a memory. It's literally a contiguous, limited, contiguous and limited space. So we have like the addresses. That's a little bit low level, but we have 0, 1, 2, 3, 4, and so on. And inside that addresses, we can have other things like potato, apple, and I am not creative. So we have this. So we have the addresses, and every address holds a value. We have a value. So 0 points to potato. And remember the name point, because we will talk this a little later about pointers a little later. But let's get our feet wet with that concept, which is the memory. Every memory cell points to a value, which is stored in the memory value, the memory address. Let's actually try to make something. So the syntax to making a variable is uint, the type. Let's try 16-bit type. The type, the name of the variable, which in respect to math will be x. And okay, we have x. but x is equal to nothing. If we try to print x, and I'll show how to print it to you later, and actually, oh, it's 0. But here in Linux is actually 0, but in Windows it is not 0. Let me just delete this. In Windows the allocation is different. So let's make it equal to something. So equals 42. When we run the program, it's 42. Okay. But how can I use the variable? So we already are using, we can actually see x here is being printed to the screen with this %d inside the string, then we colon x. If we want to print another thing, we can do this, and let's print x again. So we can print x 2 times and so on. After our printing, and let's do a little funny thing, So the where is, so the answer is 42, but we are not passing 42. We are actually passing x, but since x has the value of 42, it shouldn't like display x. It will display 42. We have here the variable, and now let's try to make a variable do some stuff in the program, because we are only displaying the variable. So let's try to use conditionals. So let's use the keyword if, open and close parentheses, open and close brackets. Brackets introduce a block of code, and we can do something here. So let's actually write a comment. Print special message if the number is 42. We have here the special message, which is print f. Whoa. But we need to make the condition. So if x, we use x double equals 42. So this double equal is totally different than this single equal. This single equals makes x 42. This double equals checks if x is 42. So if we gcc main.c .out, wow, let's try to actually change x. Let's make it only 2. The answer is 2, and wall doesn't appear. So, okay, we have here. Let's try to make an else. So else. So if it isn't 42, we printf wrong answer. Wrong answer. And when we file and run, wrong answer. So now we can actually do 42 gcc main.c .out. Wow. Okay, so it's working. So this is really a basic thing, and let's try to actually print, not print, but make a full program. So actually try to make us a calculator, not a good one, but a functional one. We have index. Let's just copy this and make y equals 69, for example. Let's make a new value, 16t z equals, And we could use 42 plus 69, but that's not good because we already have x and y, so we can x plus y. Why not a? So we can actually display z. The answer is z. So if we see, the answer is 111. And I am bad with math, but I think it is 111, the sum. But okay, we have the sum, we can also subtract, and if we actually subtract, we made an error. Why? Because the answer is negative. So we need actually to omit the u to make it a signed variable. So if we gcc a dot out minus 27. So it is working. Let's try to multiply, which is an asterisk, to give us a huge number. And let's try to divide, which will give us a number as well, which is 0, because we didn't use floats. So let's try to float. Float makes a number with decimal points. So instead of d, we use %f to make it float, and it's already not working. Let's try to divide by 9 instead of 69. So 4, okay. So let's try to actually do 100 divided by 3. Let's see. It's a 33.0000. But it doesn't like do something good because we are not using all floats. So to use floats, we need to use all floats. But this is incorrect. But we cannot do anything. Computers are incorrect with floating points. So you can see it's 33.33332, which is not correct. But who cares? And okay, we have here a basic program, and we can actually go back to the hello world because this is the end of the tutorial. So thank you for watching. If you liked it, please leave a thumbs up, and I'll see you later. Bye bye.